Hello, everyone. I wish to take this time, I hope it's not too long, to talk to you about how to study, how to make it through the math courses you are taking right now. So let me share the screen. So this topic is, this clip is about how to study. I'm not speaking from, an expert. I'm not an expert in anything. But I wish to share with you, my own experience at how to study. Okay. Um, when I was in college, okay, I was, I was in the math major when I was in college. At the time, I didn't know how to study. So after I finished, I usually, always attending classes, regularly take notes. And after class, I will go to the library and start doing homework right away. And soon enough, I found that I actually don't know how to do a lot of the questions in the homework. Okay, so on the share screen, so my old habit, let me summarize my old habit. My old habits, okay, I go to class, take notes, all right? And after class, do homework. At that time, we don't have any online quizzes and so on and so forth, because I figured if I get done with my homework, I'm done. And soon enough, I found this is not working. I found it's not working. Why? Because when I'm trying to do homework, even though I thought I understood the lecture very well. In the classroom, I thought I understood the lecture very well. When I use this old habit to study, very quickly I found I can't do some of the homework questions. And that got me really frustrated. And then I changed to a new habit. Okay, soon enough, I changed to a new habit. The new habit, of course, I still go to class. Okay, when I was in college, I was always told, the professor kept telling us, if you can study the material ahead of time that is to be covered in classroom, that would be very helpful. And that makes a lot of sense to me, but to me, I haven't get to do it very often because I barely survive those classes. So in the ideal world, let me put it down there, is that study the material before it's covered in class. Okay, that's ideal. I haven't been able to do it very often. Okay, frankly, when I was a student, I made it, I got good grades. And so I wasn't able to do the ideal thing to, throughout my college, but I still go to class, take notes. And the second thing I do, okay, after class, instead of doing homework, okay, I stop doing homework right away. I start to study the lecture. Study the lecture. Go through the steps, the proofs. Study the lecture. and try to do everything the professor has done in class by myself. So instead of fall into the old habit after class, do homework and get over it, which I will never, in my observation, if you do that old habit, you never get over it. Okay, you only get over it temporarily. With my new habit, I go to class, take notes, and after class, I study the lectures, try to do everything the professor has done in class by myself, which means that I close the book, close the notes, and redo the whole lecture. It was actually hard. It was actually very, very hard. I have to spend a lot of time because when you see other people doing it, it seems to be so easy. It even seems so natural. Try to reproduce those things. I'm not just saying simply reproduce. You have to reason your steps through. But when I try to redo those things, I realize there are a lot of reasons behind it. I even make mistakes because the professor did it a certain way, it worked. And when I was trying to do it by myself with book and notes covered, it doesn't work that way. And and then I started to question why the professor did the way he did, what she did. And this turned out to be very helpful for my study. And also, after I've done this, okay, depends on the contents. At the beginning, it was hard. And as time goes on, it becomes easier and easier. And if I do the new habit, I found it much easier when I hit homework. And number 3, I started to do homework. Easy. So that's my new habit ever since. And I made it through colleges, with degrees. So I got to teach here. So when I teach you guys, most of you guys are not in math major. Then what do you want to get out of this? Right, that's the next question. As a teacher, I've been thinking during my teaching career, what can I help you to get out of this course? Number 1, you're not math major. Number 2, you're taking this only for requirement. And number 3, you're not going to use the theorems, the techniques, you learn from this course very much in your life. Because you're not going to be teaching like me after I got my degrees. I teach most of the time in my career for life. So what do I want to help you to get out of these courses? Right, that's question. So let me write down that question. Questions, right? What I can do to help you to get something worthwhile, something to benefit your life or benefit for you, to benefit you. Okay, what can I do to help you to get something to benefit you even after you're taking this course? Even after you take this course. Number 2, right? I wish to know what you want to get out of this course. Is it just a passing grade and then you forget about it? Right? And of course, as we discuss this, some other questions may come up. So I decide that, first of all, I have a look at my own experience. Yes, I teach math for a living. Okay, I get a paycheck. But has math really benefit for me to go through my life? Well, at this age, I think I can tell you the answer is yes. I made a lot of personal decisions, applying a little bit of my mathematical training. I have, okay? In practical matters like getting mortgage, car loan, these matters, then you say, well, to get those, you don't need calculus, you just need algebra. True. But in some other aspect of life, I think even on life and death, I say it so gravely. It may sound like it sounds like a little scary. And yes, I do have a life-death situation that I get to apply mathematics, not in terms of theorems, is in terms of logic, and how to observe numbers, and get to know the meaning of numbers. The reason I was able to ask those questions, the reason is that I was able to ask those questions, I think, is mostly because of my mathematical background and my training. So my old habit, new habit, logical training in math. Some people say math is about numbers. I disagree. Math is not about numbers. Math is about logical relationships between numbers. And math teaches us how to think logically. Okay, so I'm going to put down these words. Okay, math is about logic between numbers. And number two, okay, number two is that math is about how to think logically. Okay, so math is a language. Math is a language that allows us to think logically. To think logically is ever more important. So reflecting on my own experience, and I wish to answer these questions. So what you're getting here is a training, so that you may think of things more logically. Okay, of course, the other side of thinking logically is thinking emotionally. Do I think emotionally sometimes? Of course I do. Of course I do. But in a situation that it does require us to be calm and going inward and think logically, and that's when mathematics may be helpful for us. All of us have some logic in us. It's just we want to get a little bit more of it. just apply that and be more systematical when we analyze situations. Okay. I may or may not, we may not have time to talk about my personal experience in a life death situation and decision. I will probably talk about it another time, but first let's get to this topics here. This topic is, what can I do to help you to get something to benefit you, not just today or this semester, but for the rest of your life, maybe, hopefully, is that I hope to instill the sense of logic. Okay, I hope to instill the sense of logic between numbers. From one step to the next step, there should be some logic. There should be some support. And those support can be truth. It can be falsehood. And you need to make sure you have those truths. You have those truths, in you. And we're going to learn about a lot of truths in mathematics, right? If you look at the other side of the flashcard, this is a sequence of flashcard I prepared for my calculus class students. And for those of you who are listening to this lecture, right, to this video, then you understand that you are either taking pre-calculus or you are taking calculus right now. So, and I have over 100 pieces of cards. That's the flashcards I prepare for my calculus class students. All right, so I hope to instill some sense of logic between numbers. And secondly, I hope that just like how mathematics training has benefited me personally, and we can think more logically and more concisely, okay, with more time allowed for ourselves to think for ourselves instead of just follow the crowds, okay? So that is what I wish to help you to get out of this course. So you can see, how do I achieve that goal? Okay, number one, when I mentioned that the old habit, right? We get homework done and we get quiz done, we're done. Well, that's not so, okay? Because for a calculus class, the real important thing is to learn about all these different flashcards. And some of them are logically related, how they're related. And that's number one. Number two, how to apply them. So this is our new language. The first one, for example, is very common sense, right? Any number times one stay the same. And second one is any number adds zero stay the same. Common sense. We can call, these are truths in mathematics. And third is if statement. If A is the same as B, then A plus C is equals to B plus C. And there's no specifics about ABC, so ABC can be any number. Okay? E is if A is the same as B, then A times C is B times C, provided C is not zero. And these number 3, number 4 are the properties we have used forever solving equations. Number 1, number 2, we have used forever in our mathematical manipulation. In fact, most of the algebra contents, your prerequisite contents, they are all based on these 1, 2, 3, 4, and there are 2 more mathematical principles. If you master these 6 principles and you use them, and you see them being used over and over again, it's just a matter of practice, that you don't have to remember 1,000 things, not even 100 things. You only have to remember 6 principles, and you will see how these 6 principles guided our steps. So let's look at principle number 5 and number 6. right? Number 5 says, if the product of two numbers is 0, then A is 0 or B is 0. If you close your eyes, you think of the statement of this mathematical principle, then you have to agree. This is very common sense. And last but not least, the 6th principle is that we have learned a long time ago is that a positive number times positive number is going to be a positive number. A negative number times negative number is going to be a positive number. And the rest is about, dividing positive by positive, dividing negative by negative, multiply positive with negative is negative, and so on and so forth. Absolutely common sense. And yet, we use these 6 mathematical principles for the prerequisites of calculus courses. And if you take any subject, okay, you take any subject in your prerequisite course, I can tell you where these principles are being used. And of course, we have learned some other definitions for sure. So now, in the calculus course, right, we got definitions just like in algebra class. But the thing is, in algebra class, we didn't have a lot of definition. We really did not have a lot of definition. So before you take calculus, what are the important definitions and the logical relationship we need to study, right? Number 1, function. Function actually covers most of the activities we did before you take calculus. And so before you take calculus, all you studied is function. Then you say, how so? I hardly remember that word. True. Some of you may remember that word. Some of you may not remember that word. But it's okay. I'm going to give you the perspective. Okay, I'm going to give you the perspective. Function. So first look at the function. So a function is a rule that assigns each input exactly one output. Okay? A function is a rule. So a function really is a rule. Okay, let me box this. It's a rule. Oh, and I'm going to box this. A function is a rule that assign each input exactly one output. Exactly one, that's a keyword. That's a keyword. So if we use a graph and we know that, oh, function is a rule, and we call the rule function. I'm going to use a shorthand notation. F is the rule. And it takes input, right? It produces output. It produces output. And of course, you guys have been taking algebra classes, so we use symbols to represent input output. So sometimes we call the input X. It doesn't mean we cannot use other names for input X, right? And the output is Y, right? So that's the relationship. So function is a rule. Function is a rule. But in this course and in previous courses, or whatever course you're taking, whether you're taking pre-calculus or you're taking calculus, I wish to introduce you this new notation, if you haven't learned that already, is f of x. So this notation tells us the rule is f, the input is x, the output is the whole of it. This notation is absolutely used because it is so condensed and simple, and yet it tells you all about the function. Input, the rule applied to the input, and the whole of it is the output. Okay, I want you guys to get used to this. If you haven't, get used to it already. Now, I said everything you did before you enter calculus is about function. I'm going to give you some examples of function. The first one is that you have a constant, right? And the next one, okay, I'm just giving you some simple examples I call basic functions, x, right? Another function, I would say x squared. And between c and x, right? You guys probably have learned an adding, subtracting, multiplying, dividing composition of functions. So between these two functions, we can create another function you might find familiar, mx plus b. Oh, mx plus b, right? We learned that in elementary algebra. At that time, function concept may or may not have been introduced to you, are actually doing it. You're actually doing it. Okay, so this is the category, and we usually study that in part of the elementary algebra. And continue, you have x squared. And with x squared, x and c, we introduce another more complex function, which you have seen in algebra classes, is ax squared plus bx plus c, where we say a cannot be 0. It's just to guarantee it's going to be degree number 2, right? These sound familiar, and in fact, all of these are functions. All of these are functions because each one is a description of a rule. And the rule, for example, the rule for this one, right? Suppose I'm using this rule, right? So use this example. I'm gonna see it from the perspective of rule. Then I have an input, right? And I take that input and I'm going to multiply that input with m. And then after I multiply the input with m, I will plus b. And that's going to be my output. Boom. In this perspective, we learn about function. So whether it's being called a function in the course at the time or not being called a function, you are studying function. And we have been studying functions. All right. So with functions, naturally, you'll be asking the question, I wonder what numbers will be qualified to be the input. And if I can find all those numbers that are qualified to be the input, i.e. produce exactly one output each time, right? What are all the possible outputs? So this is when domain and range is introduced. That's why for each function, we want to know its domain and range. And in these three examples we discuss, and it's a tweaked form, right? And they're tweaked form, and I can totally use f of x for these notations, right? Well, we are concerned about their domain and range, and for these three and their tweaks, the domain is all real numbers for mx plus b. Okay. How about for quadratic, right? This one has a specific name in mathematics. We call it quadratic function. And there we go. The range is not always all real numbers because we have the parabola. We're not going to get into those details. So we want to study the domain and range of each rule, which we have been studying in the course. So after the domain and range study, what else do we study? We're going to study another prospect about the rule of function. Okay. Then you say, well, if I know input, can I find output? Of course, if you know the rule, you can find output. Okay. So this activity, right? Take the example of x squared, right? If I know the input and I want to produce output, so I'm going to do this for a number of, let me increase the number of rows. There we go. Okay, I'm just giving you some examples. So this is the input, and that is the output. All right, the input is x, the output is f of x. And suppose my input is 0 and my output is going to be f of 0. Notice how I read it, f of 0. So I get an output 0. Suppose my input is 1 and my output, by replacing the input, I get output, right? Because I know the rule. Whoops, suppose my input is -2, then my output is going to be, input is -2, the output is +4. Right, so domain and range, and we have identified domain and range, and then we plug in, right? Have we learned about plug-in before? Yes, plugging in is a process of giving input and plugging in to get the output. So for each input, I get exactly one output. Each input, I get exactly one output. So I have many such input-output pairs. So this is the time we say, oh, let's put them together, input output in pairs, and they're called ordered pair. Right? So the first one is input 0, output 0. The second one is input 1, output 1. And the third one we have the example. I don't have time to do all of it in great details for this specific function. We just want to illustrate the function concept. So the ordered pair, we plot those points, we get a graph. And that process is called analytical geometry. Digitized processing of function. Okay, so these words, they come because whenever you hear analytical, usually is about digitized. Okay, so you can do these for all of these functions, input, output, right? So these examples is going from input, is a given input, find output. So that direction, right? From input and produce output. On this aspect, we have done a lot of it in algebra. We've done a lot of it in algebra. All of the graphings is that, excuse me, all those graphings is done in this perspective. And then you say, well, if from input I get output, right? How about if I know output, can I get input? The answer is yes. The answer is yes. Sometimes, not always. Right? From output to input is another matter. Output from output to input is another matter. Is even output, we find input, right? So what are those situations? What is the story? For example, and this is a situation, it involves if statement. It's a if, right, from output to input. If x squared is 4, right? And then you're told, please find all possible, find the solution, find the solution. Well, this is a typical of knowing the output and we want to find input, right? So the kind of question we encounter in the past is either from input to output or from output to input. Only two kinds of questions, only two kinds of questions. So in mathematics, most of the time, kind of question you're dealing with is either from input to find output or from output to find input. I haven't seen the third type. I have not seen the third type in my entire career, teaching or as a student. Just two type. It's just how you see it. What's the perspective, right? So for example, in the second case, right? So first case we did from input to find output. And the second case, from output, we want to find input. Okay, so I'm gonna get rid of these, right? And domain and range, I'm gonna put it on the top. And these questions typically show up in our narrative, in our dialogue as equation. Okay, equation is deal with this kind of thing. So in your past experience, you might learn that one is evaluate expression. Evaluate expression is from input to output. And solving equation is from output to find input. That's all. You only have these two kinds of questions. Okay, now what does it mean by finding the solution? Finding the solution meaning, okay, find all possible input such that this statement is true. And this is the so-called solving equation in your previous experience or in my previous experience. But now I put it all under the function perspective, under the umbrella of function. Okay, let's see. Technically, of course, you know how to do this, right? So how do we solve it? So when we solve this, right, we just talk about mathematical principles, number 3 and number 4, right? How do we solve this? Because this is under, equation is basically an if statement. For if statement, we can use principle number 3 and principle number 4. So when we solve this, when we write this down, there are actually some words we're kind of skipped. What is that word? That word is if. If x squared equals to 4, right? So in our mind, we need to read it as such. So if x squared equals to 4, then I take square root. Excuse me. On both sides. And square root of 4 is 2. Right? And the square root of x squared is absolute value of x, which is equal to 2. So if this is true, then this is true. If this is true, then this is true. If this is true, what are all the possible numbers such that the absolute value of it equals to 2? That would be x equals to -2 or +2, meaning that if -2 is plugged in as the input, it will produce the output 4. If +2 plug in this rule, it will produce the output of 4. Okay, so this is the situation from output to input. Okay, you can do it as a graph, right? But this is the if statement. But what if I have another if statement? I say, okay, I'm going to change the if statement. So if x squared equals to 4, I make it equal -4. So can we find such input such that the statement is true? I hear you. You will have to go to complex number, right? But if we insist on real number solutions, then there's no real number solution. There's no real number solution. No real number solution. There are two complex number solutions, which are x equals to -2i, +2i. However, in this course, whether pre-calculus or calculus, for these two courses, we are only concerned about real number solutions. We're only concerned with real number solutions. So in this situation, what do we say? No real number solutions. We can see sometimes when we try to find the input from output, sometimes we have solutions and sometimes we don't have the desired solution in the desired range. Okay, so that's why we use if statement. It's a big if. It's a big if. When we have a big if, that it may happen or may not happen, doesn't it? Okay, so this is the function concept that I from which you can see now if you recall what you have learned before, and they all fall into this umbrella. They all fall into this umbrella. Okay, so let's see what other functions we're going to see. So in this part, the only concept you need to understand and apply, this relates to how to study. You just apply the definition of functions over and over again and use it to determine domain and range. Okay, so what are these functions? We have many of them, right? All those functions I have listed, there's logarithm functions, right? Just to name a few, exponential functions, logarithm functions, and trig functions, and et cetera, et cetera. Okay, there are, arctan functions and so on and so forth. All of these functions, they all have specific rules. They all have specific rules. Okay, for trigonometry, it might take another review session, but it's also a rule, but that rule is just a little bit more complicated. Okay, and the exponential logarithm rule is a little bit more complicated than the algebraic rules, and trig function rules are a little bit more complicated than all of the rules above. Okay, so when we study, what is the focus? Right, because in this lesson we talk about how to study. Right, in algebra class, really your focus is 1, 2, 3, 4, 5, 6, these 6 mathematical principles. Okay, and of course a lot of practice to handle rationalization, factoring, And then you say, why factoring? Why factoring? Right? We spend a lot of time factoring in our algebra classes before we enter calculus. Okay? The reason we factor so much is actually because of mathematical principle number 5. And the other reason that why we factor so much is mathematical principle number 6. Because once we have those factored form, not only sometimes it helps us to reduce, it also allows us to use mathematical principle number 5 and principle number 6. So factoring as a technique is indispensable. It's indispensable that you have to be really good at it. So in our first week review session, I have done some examples for you to review those factoring techniques. So this is true for both courses, pre-calculus and calculus. Okay, so now you can see the 6 mathematical principles, right? When do we get to use them? Oopsie. Number 1, we use them to rationalize. And, all of these are for mathematical manipulation. Number 3 and number 4 is for solving situation from output to get input. Number 5 and 6 is very versatile, is to simplify your situation, okay, reducing by factoring. And of course, you might be thinking of, oh, what if I cannot factor? Well, what if it's very difficult to factor? That's a different matter. We're trying to not get into those details, right? So now you think back your pre-calculus experience. 6 principles cover them all, and plus a couple of definitions. And what else those other definitions we're talking about? Right, so we have the first definition. We just have the first definition. We already have covered so much, right? The second definition is a one-to-one function. One-to-one function. One-to-one function says whenever, right? It's still about input-output, right? Is whenever the input are not the same. Input 1 is not the same as input 2. Not equal. Then f of x1, f of x sub 1 is not going to be the same. This is so-called horizontal line test, right? One-to-one function. So the first important concept is a function. Once you have function, you start to consider whether it's a one-to-one function, right? And what is not a one-to-one function, all that discussion. And what else? Increasing function, decreasing function, even function, odd function. Okay, so that's even function, right? Odd function. Increasing function. Decreasing function. So that those are all the concepts you learn. Besides those, how logarithm is defined, how trig function is defined. Okay, these are the 1, 2, 3, 4, 5, 6 definitions all for all functions. Every function you have studied from time to time, you might have been talk about, oh, this is the even function, this is the odd function, this is the decreasing function, and so on and so forth. Okay, so you have touched those concepts before, so now I'm just going to bring them together. What is even function? Even function is when the input are opposite. Input are opposite. So x and negative x are opposite. And when we apply the rule on these two functions, we get the same output. So the definition for even function is such. Opposite input produce the same output. And this is true for all x in the domain. So this is true for all the x in the domain. How about for odd function? Odd function basically says when the input, right, are opposite, the output is also opposite. The output is also opposite. And this is also for all input in the domain. Even odd, right? In trig function, we study even odd, sine is odd, cosine even. When you review that, being aware of that, that's why even odd has been discussed a lot. How about x squared? X squared is even. X cubed is odd, right? And another function, we can think of is that, say for example, f of x, the even function we have learned, right? One is x squared, right? The other one is absolute value of x. It's a very important function. And these are the evens examples, right? Even function examples. And cosine x, right? How about odd? The examples of odd. Well, the example of odd would be like f of x equals to x to the power 3, right? X is odd, sine function, tan, cotangent, right? And this one would be secant and cosecant, and so on and so forth, right? So we can do these classifications. So even odd. So for all the function we study, a lot of the cases we consider these. That's all the definitions you have. Okay. And now let's look at increasing function, decreasing function. Increasing function, decreasing function was definitely studied. But in calculus class, we're going to use more of it. Okay. In several weeks. It's better we get discuss it now. And what's the definition of increasing function? I'm going to copy and paste so you can see the change. Whenever one input is less than the other, the output is also one is less than the other. And for what's decreasing? Decreasing is saying whenever one input is less than the other, the output is the opposite. Increasing, decreasing. So these are all the concepts pertaining to functions so far before you enter calculus, right? We have studied so many functions from this summary. So what's our focus? Our focus is on definition, domain range. Okay. And I have a lesson in the function review. Okay, which is about 1 hour, 11 minutes. That was posted in the first week. Okay, it's posted in the first week. Function review function. So that focus is on definition of the function domain and range. We're going to use a lot. All right. Now, as we enter calculus, how do we study? Right. Focus on the definition, the theorem. So remember my experience, right? The old habit doesn't work. So after each lesson, you need to study the notes, reproduce everything in the classroom, and you do homework like a snap. Easy. Easy. But if you don't do this new habit, you're going to be forever struggling. You're going to be forever struggling because you always say, how should I do this? How do you know how to do this if you don't study the lecture? Because in the lecture, in the lesson, it tells you how to study, how to do your homework. But is homework the centerpiece of what we need to know? The answer is absolutely not. Okay, so look at the flashcard. Look at the flashcard. We have over 100 of them here. I just pick one randomly, right? And you know, some of these definitions, and you know, for example, this definition about limit. Pre-calculus class student, you're not going to see this, but you're going to see it next semester. Right? This theorem is the centerpiece. You find that you have a lot of homework questions that you get to use it. So in the lecture, the professor will show you how to use it. So after class, you're going to study those examples the professor talk about, how to use it, and you think of it. You're going to apply that theorem to your homework. Okay, so you don't need to invent anything new. You just take this language and the principles, the truths we learn in mathematics, and of course, it require us to be familiar with those truths in mathematics and apply it to the homework questions and to the quiz questions. So once again, since this is the first time I talk about how to study, how to focus, and how to, you know, master those principles, which is that they're not very many. And in the future, if necessary, I'll make more of things like that. So first, I'm asking you to please adopt this habit or try something different from what you used to do. Make some adjustment. Okay, do homework quizzes if there's any, right? So I promote these new habits. If you can add a little more, it's ideal, but it's difficult. And know your focus. Your focus is always those principles, those definitions, those theorems. So learning this language is, in homework, is about how do you apply those theorems? Typically in the textbook, they're being boxed. How do you apply them to your homework questions? Anytime you're not applying anything you learned in the course, anything new in the course, you're not doing yourself a service because you're doing something else we don't know and irrelevant to that course. Even though you might get the answer right, if you don't think those contents, those centerpieces, which you know, there are many. If I look at the textbook for this semester, there are about how many pages? Let's see. How many pages for the first 5 chapters, which we're going to cover? That's 434 pages. 434 pages. Okay, 434 pages right here. Okay, 434 pages of content. Of course, some of those is a little bit just empty page or stuff. 454 pages condensed into just a little over 100 flashcards. And those flashcards content is the centerpiece, is what we need to focus on. And we not only need to understand those definitions, theorems, and so on and so forth, and we're going to apply them to homework and exams. And that's really what we are doing here. And by doing this, we need to understand the logic between them and how to think logically, how to think mathematically. We allow mistakes. Mistake is the best way to it's still one of the best way to learn. Okay, if you never make mistakes, you probably won't learn as much. Okay, so do not be afraid to make mistakes, but follow these I would say beaten paths. People have tried these for a long time. It works. Okay, but I'm not saying you should not invent your creative new methods. But before you testify your new creative method works, how about you try something that has proven to work? All right. So I think that's all for this lesson. I hope it might be too long already. Forgive me. Thank you for watching. I will see you sometimes.